Hello everyone. In this session, we're going to talk about Ipv6 addressing. An Ipv6 address has 128 bits. These bits are divided up into fields. Each field has 16 bits. IP6 addressing is written in hexadecimal format. Each field is separated by colons instead of a dotted notation as we have in Ipv4. From our previous sessions, we would remember that an Ipv4 address had 32 bits with 4 octets, 8 bits per octet. This is an example of a hexadecimal Ipv6 address. And we can see that the fields are separated by colons. Let's take a look at how we would convert the hex number to binary. On the right-hand side, we have a table showing us hex numbers, and they go from 0 to 9 and then A to F, and the binary equivalent. To convert a hex number to binary, we simply write down the binary value of each hex digit. For example, if we had the hex number F8 and we wanted to convert that to binary, we would write down the binary for F. And we see that the binary for F is 1111. And then we would write down the binary for 8. The binary for 8 is 1000. So therefore, our answer would be 11111000. Let's look at another example. We wanted to find the binary for the hex 1A. We do the same thing. We find 1, and we see that the binary for 1 is 0001. The hex A, the binary for A, would be 1010. So the answer then would be 00011010. Note here that you can ignore the zeros at the beginning of the hex number. So that if you had 0001, it would be the same as 1. So we have here 00011010, and if we ignored the 3 zeros, then we can also write that number as 11010. Let's look at converting now the binary number to hex. So let's say you were given this binary number, 11010, and you needed to convert the binary number to hex. Here, because the number of digits is not a multiple of 4, you can go ahead and insert zeros at the beginning to make the number a multiple of 4 just for conversion. So it will become 00011010. You then would separate each 4-digit pair and you would get the corresponding hex values. So you would have 0001, which would give you 1 in hex, and then 1010, which would give you A in hex. So the answer would be 1A. Most IP6 addresses do not occupy all of their possible 128 bits. We can shorten the IP6 address by abbreviating it. Now, let us look at an example here of a IPv6 address. We have within this IP6 address a contiguous set of zeros. That means a set of zeros coming together, two fields of zeros, one after the other. We can shorten that by representing the contiguous set of zeros with a colon. So instead of writing out this whole hex number, we can shorten it by putting two colons to represent the two fields of zeros. If we have other fields of zeros within that same hex number, we can also shorten the address by representing the other zeros with a single zero. So within the hex number, we can only take a set of zeros and represent it with the colon. If we, in this same address, had another set of zeros, we would have to represent those zeros by a single zero. Remember that we can also omit any leading zeros in the field, which would further shorten the address. So that we could take the 0db8, we could take off the 0, and we could make it db8. So you see here we further shorten the address. And then the field that has 0015, we could remove those zeros and we would have 15. So this address would be shortened even further to 2001 colon db8, we took off that 0, colon 3c4d colon 15, we would have taken off the two zeros. And then we have the two colons representing the two fields here of zeros. So we can shorten or abbreviate the IPv6 address by representing a set of zeros with two colons. And if we have other zeros, we can represent that with a single zero. And if there are any leading zeros within the IP address, we can remove those leading zeros to further shorten the address. Let us look at an example of a company that has been given an IP address by the internet service provider. The company has been given 2FFE colon 1000 colon 2000. So we have 16 plus 16 plus 16. So remember, each field has 16 bits. So this address here is representative of 48 bits, 16 plus 16 plus 16. The way we would write that down is 2FF colon 2FFE colon 1000 colon 2000 slash 48. What does that mean? It means that this first section of the address here is referred to as the network section. So the first three fields in the IPv6 address represent the network part of the address. In an IPv6 address, the last 64 bits, which would be the last four fields here, are reserved as the host bits. Again, the first three fields represent the network. And then we have the fourth field, which is the field that we're going to use for subnetting. So let's take a look and see how we would subnet using the fourth field. Let's say that your ISP has given you this IPv6 number, but you have a /56. Remember we said that the first three fields would be the network part, and that is 48. So if they give you 56, you would need to borrow, you would need some bits from the fourth part, which would be the part that we subnet with. So if we took 6600 and we converted that into binary, this is what we would get. 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0. So if this part is 48, we can start counting. It's 48 is the network part. 49, 50, 51, 52, 53, 54, 55, 56. And that's how you got 56 here. So the number of subnets then would be 2 to the power of 8, which would give us 256. In our next session, we want to look at the different types of IPv6 addresses. This is the end of this session, and I want to thank you for listening.